Welcome everybody to an event organized by the American Nuclear Society's Risk-Informed, Performance-Based Principles and Policy Committee. We call it RP3C. My name is Prasad Kadambi and I am chair of RP3C. The purpose of RP3C is to help modernize ANS standards. Modernization has come to mean that risk-informed and performance-based methods are employed to overcome the difficulties that we all have encountered with purely deterministic and prescriptive approaches and methods. We've been calling these approaches and methods RIPB for short. The Nuclear Energy Innovation and Modernization Act specifically mentions RIPB. If you look around, you will find it hard to find any place other than ANS, outside of NRC, of course, that has as much information and guidance on RIPB. Overall, there's a lot of guidance available on RIPB, but most people have not had reason to become familiar with the information. This is primarily because the conventional approaches still dominate most things we do, including standards development. RP3C has been having these community of practice events regarding RIPB and the associated methods, such as systems engineering, to enable practitioners to share their knowledge and experience. We've been scheduling these sessions for the last Friday of each month. This month, I'm hosting the session, and what I want to talk about is really my own personal views, and I don't represent either the committee RP3C or the ANS. What I would like is a technical feedback, discussion, and exchange of views. Next slide. So the question I pose is, does RIPB handle safety margins differently than conventional approaches? I offer a structuralist perspective of this, and for people who have been around, you may recognize this term going back 20 years during the discussions of ACRS. I'll address safety margin in different contexts. But most importantly, I'll go back to the NRC initiatives with Commission direction 20 years ago, which turned out to be critical for licensing advanced reactors in a technology inclusive manner. So I'll also describe a document in which I had a role, NUREC BR 0303, and also try to touch on what RP3C is doing to modernize ANS standards. Next slide. So this slide essentially was presented by Stu Magruder of NRC staff, who made the community of practice presentation last month in April. And he offered this in the context of how the staff reviews applications for advanced reactor licensing, and how they use the RIPB methods, and what in the regulation makes that possible. This excerpt clearly describes what NRC will be looking for in an application within the licensing process. Stu highlighted the need to include determination of safety margins of safety as a technology inclusive factor for evaluating applications. Now, 10 CFR 5034A applies to PSARs, and therefore it can be seen as a minimum set of technical information to be provided in an application. The assessment of risk is clearly a performance objective to be part of the licensing. Also, it has to address normal operations and transients over the life of the facility, and all of that should be considered. Defense in depth is touched on as the prevention of accidents and the mitigation of consequences of accidents. Next slide. So taking a closer look at the rest of 5034A shows, in my view, a hierarchical structure. So the requirement in 5034A4 is the result of implementing a sort of a higher up feature of 5034. And that is 5034A2. I call it higher up in the sense of there is a relationship in which the lower levels are contribute to fulfilling the performance objectives at the higher level. And so 5034A4, which has the features that we talked about in the previous slide, essentially addresses the fact that design and operating characteristics have to be considered. Unusual and novel design features have to be described, and principal safety considerations have to be presented. So I view the principal safety considerations aspect of this as being essentially what we these days call a safety case. And that has a sort of superior position, in my view, to the principal design criteria, which appears in 10 CFR 5034A3. So principal safety considerations is really where it becomes amenable to use the guidance on performance-based regulation, Reg BR 0303, in a more explicit manner or formal manner. Next slide. So in terms of what does a designer do, the performance expectations associated with the design, I would expect that the designer will want to address the key regulatory expectations. And those would be, based on analysis and evaluation of the design. And that includes functional analysis that covers design and operational phases. It would be based on modeling and simulation quite a bit. The performance relative to risk, would have to be considered. And these days, the way I look at it is that design and operation are to be considered in a continuum. But finally, we end up with being able to identify and determine the margins of safety. Next slide. So So I'd like to spend a bit of time looking at the concepts of safety margin and margins in general. You know, the common language understandings, the easiest to go to would probably be profit margins, you know, which are a difference between the sale price and the cost of manufacture. But as we all know, these things start off simple, but can become very complicated quickly. For example, if you think about the posted speed limit on our roads, you know, it's generally posted at about 55 miles an hour. But if you're traveling at 56 or 57, would you really get penalized for it? Highly unlikely. But what is involved is that there is a margin for enforcement of the speed limit. And generally these days, that's about 10 miles an hour. So if you go at 65 miles an hour, you can expect to, you know, get a ticket. Similarly, it can get complicated when, you know, if you don't consider margins and look at an issue that is frequently faced, especially in the past when the regulatory regime was more strictly compliance oriented. Strict compliance with a requirement versus conformance with performance objectives. The thing is, as we were developing the guidance for performance-based regulation, it was industry input that spoke to us about the perverse incentives within the regulatory practice that sometimes contributed to loss of safety margins. And so there was expressed a need to make sure that, you know, the focus should be more on achieving the performance objective rather than literal compliance with some set of words. And of course, within standards, what we have found in ANS is that it's really quite difficult to incorporate conformity assessment in ANS standards. Next slide. So if we get a little bit more into the technical aspects of safety margins, I tend to view this in the context of the way things are done in ASME versus how, you know, the nature of the problems we deal with in ANS. So when you're dealing with mechanical components, that's the focus of the ASME standards. You know, generally it can be brought to the consideration of a strength variable and related to a load variable, and you consider the difference as the safety margin. Next slide. If we look at the sort of issues that we face in the ANS standards, you know, what we find is we're looking at, for example, things like transients, reactor transients, in which you know, there is an initiating event, and you know, there's a trajectory for the transient, and you know, what we are concerned about is what happens at the extreme points of the transient. And in this picture, what is shown is, you know, there's a probability distribution related to the variables, you know, in the transient. And of course, in terms of the margin, that probability distribution needs to be compared with a probability distribution associated with the failure. And it has to include consideration of the uncertainty and the variability of the parameters involved. So, you know, this is the sort of thing that makes margins quite complicated in some of the work that we do. Next slide. So, a more sophisticated way of depicting margins was developed as part of the research that we did in the performance-based approaches area. I want to give credit to Bob Youngblood, who has worked with me over many years, and you know, whose work I use liberally in this presentation also. You know, he and I worked on this concept of the receiver operating characteristics, which is a way to show how decisions are made under uncertainty, but also ambiguity. So, you know, this is how practical decisions have to be made, where you have to consider margins. And this technique allows you to sort of just pictorially represent where you have abundant margin and where you might just have some margin, but you know, and you know, you don't know whether that's enough for what needs to be done. So you know, that's where the evaluation comes in. Next slide. Now, this is getting a little more into the details of how margins can be quite significant in the work that is done in reactor safety. This shows that you know, there are conditions where the level of detail in the consideration of margins can become really quite significant. This picture depicts you know, a set of events related to the large break LOCA that goes into the recirculation phase. And it's something that's associated with what has been called the generic issue 191 on debris accumulation. The yellow part, the design basis, is where adequate cooling in the recirculation mode occurs. Now, in terms of how the modeling on it is used, you know, it's the area where related to margins, you would rigorously validate the margins there. But if you start considering, you know, lower frequencies of the sequence, where you think about plugging and you know, get into the area of beyond design basis region of the sequence, then it's just not practical to validate the models. So you have to deal with the fact that the margins you may be able to estimate, but you probably will have less confidence in the magnitude of the margin. So, and this is a type of analysis I expect is very much a part of the framework that has been developed for the licensing modernization project. So, you know, this is all coming together in a way that is a consistent set of methods, you know, in terms of how Safety margins are used for advanced reactors. Next slide. So if you're able to determine the margins in a satisfactory way, then what becomes possible is that you have the possibility of a sort of negotiating between the allocation of margins for different uses. So this is where when people say that there should be flexibility in the regulatory regime, you're really talking about how the margins are allocated in such a way that the licensee has the ability to use the margin, for their for their purposes, as much as the regulator has the need to use the margin to make sure that safety limits will be observed. Next slide. So, all this can come together in order to address the needs of defense in depth. And the way this picture addresses defense in depth is to say that you can view the layers of defense as like slabs of Swiss cheese with holes in it, and you will be able to determine vulnerabilities when the layers of defense somehow come together such that an event will bypass all the layers of defense that you have designed into it. So this one way of looking at the layers of defense that is proposed in the licensing modernization project is a search for vulnerabilities in this way. Next slide. So now let's move into what were the commission initiatives that really made, in my mind, a lot of these things possible over the last 20 years. Now, we pay attention to what the commission says so that we can get the staff to focus on what matters. In some of these cases, the staff has a tendency to practice regulation in the way that it has happened in the past. But in my mind, what the commission did 20 years ago was quite revolutionary, and it was all part of what they call the strategic assessment and rebaselining. As part of that, there was a direction setting issue 12 and some commission direction issued as a result of that. I've identified these references over there, but the sum total of all this was really reflected in what I think of as one of the most important documents around, and that is the white paper on risk-informed performance-based regulation. That's the SRM to SECI 98-144. Now, this was issued in 1999, and yet when I look at it, Part 52, 10 CFR Part 52 was issued after this, and 10 CFR Part 52 doesn't really refer to the white paper or the risk-informed performance-based in any substantive way. It goes back to Part 50 for the technical requirements. Also, you have 10 CFR 5069 that was issued again in the early 2000s. And I look at it as a partial realization of DSI 12, but I don't think implemented the performance-based approach, in which case, if it had done it, then we would be able to focus special treatment on what actually matters. So, the fact is that rule makings, need to be brought, need to be used as occasions to remind the staff about commission direction. But one thing I'd like to recognize is that the work of DSI 12 is very much reflected in the reactor oversight program, but that was implemented without any rulemaking. So, it's just a fact that the staff does, do some of these things in my mind correctly, but sometimes when they don't, we as stakeholders, need to play a role also. So next slide. So let's take a look at the white paper in a little more details. The white paper offers, I think, a formal basis for doing for implementing risk-informed performance-based approaches for new reactors, for advanced reactors. And what it also does is offer a basis for an applicant to assert that there's a formal basis for meeting and conforming with commission expectations. And this could be done in an analogous way to the way we use the Commission Safety Goal Policy Statement, or the Advanced Reactor Policy Statement, or the Severe Accident Policy Statement. So the point is that in the ANS standards program, we are trying to do these things, whereas it appears that industry is not finding much value in the white paper definitions. Next slide. Let's see, is that the next one? Yeah, I think that's the next one. Okay, so success for RIPB methods then is to accomplish what actually matters. So the risk information is used as a way of grading the activities, and the performance-based approach provides the sound basis to show that performance objectives are being achieved. And this is done, as I said earlier, in the reactor oversight process quite well, and that's very successful. Another point about the RIPB approaches is that unnecessary regulatory burdens can be revealed, and perverse incentives can be revealed, and system responses can be optimized, and inspection and tests can more directly support safety objectives. Next slide. So in terms of where NUREC BR 0303 could be very helpful is that it could be used to propose alternatives in which we can look at how much prescriptive versus performance-based, how much do you need to rely on prescriptive methods in order to achieve the safety objective? And in general, the more margin you have, the less prescriptive you can be. And of course, between deterministic and risk-informed, depending on the magnitude and confidence in the margin, you can adjust the approach. I think it is also very helpful to be able to do cost-benefit analysis in a more transparent way, and this could be very useful in applying a systems engineering approach and apply it again all the way from design to operation to decommissioning. So I think one other thing is that the current regulatory framework offers a lot of flexibility, but you need something like the performance-based approach formally applied in order to really take advantage of that flexibility. But all the time, I go back to what one of the important aspects of what the Commission said in the late 1990s was this, this document, a yellow announcement, in which the Commission made the distinction between safety and compliance, and said that the emphasis should be on safety. Next slide. So again, NUREC BRO 303 offers, in terms of structured approach, something called the objectives hierarchy, in which you have the ability to consider, where more prescriptive approaches would be appropriate, and where it is possible to use more performance-based approaches. Next slide. So in terms of where we are with NUREC BRO 303, there are a number of documents available that elaborate on some of the basic concepts in there. And, I've shown those over here just as for reference. And I also want to point out that, there are standards, both ANS and ASME, that are, using this guidance. And, we have taken a role in the Part 53 rulemaking to suggest that there should be a role for NUREC BRO 303 in that also. Next slide. So in ANS standards, some of the things we are trying to do is RP3C is developing a guidance document, and in it, what we are incorporating is at a high level some of the lessons that come out of all this work that was done with risk-informed performance-based approaches, and make it available to the working groups that are actually developing standards. Another thing that could be done is something that came out of NRC Standards Forum last year. What we suggested there was that, the way margins are dealt with in some of these standards is very inefficient and leads to, basically very expensive applications. So, if we consider margins as one of the ways of harmonizing standards, it could result in a more efficient way of using consensus standards. Then in ANS, we are actively working. I've identified 3 standards here: 30.1, 30.2, 30.3, and I would add 20.2 to that, where I think we are attempting to really show how all these things can come together. Next slide. So in summary, it's my view that the formal consideration of safety margins is well suited for meeting the Commission's expectations relative to regulatory reform. 10 CFR Part 5034 can be viewed as a hierarchical construct, and the determination of margins of safety during normal operations and transient conditions can really be the focus of a safety case in order to meet the licensing requirements. Incorporating defense in depth in a technology inclusive manner appears inevitably to involve performance-based approaches, and a formal way of doing that would be NUREC BRO 303. And considering that NUREC BRO 303 is the only NRC approved document that treats safety margins formally in nuclear technology at this time, I think it is important to see how much benefit this guidance may offer within the nuclear licensing process. So that is my presentation, and I'd like to see if there are any questions. I see that Tim has offered a reference for the structuralist versus rationalist view. Thank you very much, Tim. We'll make sure that that's part of the record of this session. And Tom Nicholson, thanks, Tom, for joining us. Please comment on the new USNRC Be Risk Smart initiative. Okay. Well, Tom, I guess I don't know enough about that to comment on it right now. Would you like to tell us something about how that is relevant to what we are talking about today?
Yes, I'd be more than happy to comment. The NRC is involved in creating initiatives for transformation. And one of the things we want to do is across the board, not just for licensing actions, but for all actions, to be risk smart. And the issue basically comes down to getting risk-informed insights into the work we do, whether it be in research and licensing and nuclear power plant protection. So it follows similar to the risk-informed approach that you were talking in the past, which focused on safety margins and on safety considerations. But now we're looking across the board: environmental reviews, safety reviews, security reviews, all kinds of issues. So it's formulating a whole new thought pattern for the NRC staff. And this guidance that I've provided to you on the website talks about the new guidance on how the NRC staff can develop risk insights and when they approach a problem. So if you go to that site that I gave you, both the documents and discussion are there, and it certainly applies to what you're doing. Thank you.
Thanks, Tom. Yeah, I will take a look at that and I see if we can, in some way use it for our standards work also. And of course, I know you're involved with standards development, and perhaps you can help us, understand that a little bit more on how it is useful for standards.
Yeah, I'd be more than happy to.
Okay, great. There's a question about Reg Guide 1.203, the evaluation model development and assessment. Praveen Sawant, would you like to explain? I'm not very familiar with 1.203, so.
Yeah, this is Praveen Sawant. Yeah, so my question is like, say, Regard 1.203 provides a kind of guidance on development of evaluation models, a kind of a path on how to increase the confidence level in your evaluations and analysis through uh, structured assessments and validations and development of mathematical models. So, uh, uh, I'm just wondering, like, where this RIPB process, like a risk-informed process, are we kind of uh, uh, looking at it as an alternative to develop a better understanding and being to develop a better confidence in analysis?
Well, my response would be that what we are looking for is a better way of making decisions about safety. And I'm suggesting that rather than get into some of these processes of model development and validation, where so much is done about the validation, but the end point of it, I think, always has to be how confident are you about the margins that you estimate. So this is the magnitude and confidence of the margins which will feed really the decision-making process. So I think something like this Reg Guide 1203 will probably be a good basis for the process involved in estimating the variables associated with specific safety decisions, I think. Just off the top of my head, that's the way I see it. But that is the reason why I think modeling and simulation is such an important part, because we are talking about advanced reactors where we don't really have much operating experience. But our ability to model these days is just so good that we should be able to make better use of it to estimate the margins and then prove it as part of the licensing process, which is, you can build a facility and have license conditions that are based on demonstrating that the predicted margins are being realized. And I think that would be a perfectly sound way of making the kinds of decisions that licensees and NRC would find beneficial. So let's see, there's another question. Tim Drzewiecki, sorry Tim, I always screw up the name. But the question is, what level of review was done for NUREC BR 0303? Yeah, that's a good question. And I think people, don't know that much about the background because this thing got sort of hidden in the weeds. But basically, that guidance document was developed to resolve the issue that the commission asked of the staff to develop a guidance documents for performance-based regulation, and I was the main lead on that. And we went through a public process of inviting industry participation in providing comments that we included in developing the guidance, and then took the guidance to ACRS for review. The ACRS approved it, and we sent it up to the commission, and essentially said that we have accomplished what the commission asked the staff to do in terms of developing guidance for a performance-based approach. So, to that extent, it has gone through the entire process. But of course, in terms of OGC, the General Counsel does not necessarily have a role in the technical review and approval of something like this guidance document. So I believe I did have OGC input in it while I was going through it. I know that I worked with a person on the OGC staff, but there was no real need for a formal OGC, approval there. Any other questions? You can open up and use the voice system to ask if you wish. Okay, since I don't see that there are any questions, I really want to thank everybody for participating in this session. I hope you found it helpful. If you have any comments, I would love to hear from you. And of course, please consider joining our effort in RP3C to bring more of these practices into the mainstream.